The probe drifted further, snapping these remarkable images all the way down.
We all kind of saw, our backyard in Arizona or the French Riviera, wherever it was you were from, you sort of saw some aspect of Titan that looked familiar.
They were everything that our images from orbit were not, because you could see a dendritic drainage pattern that looked like a river system, just like a river system would appear on the Earth. Boy, that was heady. That was like, ooh, it was like Jules Verne come true. It was just spectacular.
Paychecks.
Huygens landed on Titan. It sent back these few hundred pictures until the batteries died and the probe froze solid.
The probe landed with a thud on basically a streambed, an area littered with rounded cobbles that showed that these little rocks or ice particles had been tumbled around in a stream at some point in the past.
The whole thing just was very chilling, not in the sense of temperature, but just in the sense of what we were looking at. It was very, very alien.
It's not a place where you want to just jump out there in your shoes and socks and shorts and t-shirts. It's roughly 200 degrees Fahrenheit colder than dry ice.
With a surface temperature this low, nothing is what it seems on Titan.
Titan is a world with liquids. The difference is the liquid is not water. The liquid is methane. Think of gasoline. It's a liquid like white gas.
So you've got rivers of methane flowing on the surface. Anybody who's looked out of an airplane window flying over deserts and things like this say, yeah, I sort of understand what's going on the surface there.
Because it's so cold, water behaves like rock does and methane behaves like water does, but everything's just sort of shifted along a scale of volatility.
How do you end up with a landscape that looks so much like home on a world that's so different? Methane soaks into ice like water into the ground, and just like on Earth, any overflow will cut its path downhill.
Titan would be a wonderful place to visit. Stand next to a babbling brook of liquid methane running by your feet, and I sometimes wonder, well, what would that sound like?
In fact, as we took radar pictures of other parts of Titan, we found even wilder things in the northern polar areas. There are entire lakes or even seas that looks to all the world like you could go take a boat and go to jet skiing or something, right? Up and down these channels there.
Titan is the only other place in the solar system that we know liquids exist on the surface. So here you have vast reservoirs of liquid natural gas, and oh, by the way, we have thrown in some ethane, which is a slightly more complex hydrocarbon, and oh, by the way, there's some propane in there. Everybody knows what propane is, so use it in your backyard barbecue.
Cassini's radar spied lakes as big as inland seas, even bigger than Lake Superior.
Imagine standing on the shoreline of what to you looks like an ocean of liquid hydrocarbons. That's got to be pretty special.
And if you think the lakes are weird, try the volcanoes.
We think the material that comes out of Titanian volcanoes is a mixture of ammonia and water, which allows water to melt at a much lower temperature.
This is lava on Titan, a stinky mix of water and ammonia, molten at minus 150 degrees.
You can build anything from small cones to large mountains on Titan out of this stuff. If you were a visitor and you walked up and put your hand on a lava flow, you wouldn't burn your hand, you would freeze it.
In stark contrast to the cryovolcanoes and wet polar lakelands, bordering the equator are vast Titanian deserts covered in dunes.
I think it'd be one of the 7 wonders of the solar system. What you'd see is almost unending sea of massive dunes, exactly the same size and scale of dunes that we see on Earth. Some areas where you see nothing but dunes for hundreds and hundreds of kilometers.
The byproduct of billions of years of production from the chemical smog factory in the upper atmosphere, the grains in Titan's dunes may literally fall from the sky. Like a rain of flash-frozen coffee grounds, they are swept by the wind into deep piles that cover 20% of the surface. And like a good coffee, these Titanian dunes are dark and rich.
The dunes represent a massive inventory of organic material, hundreds of times larger than all the coal, for example, on the Earth.
You're not likely to be hauling this alien coal home, but the liquid hydrocarbons lapping on Titanian shorelines could be very useful for the return trip.
There's more, let's call it fossil fuel type energy than we actually have known reserves on the Earth by a factor perhaps of 10 or even 100.
That's a lot of gas in anyone's language. But something even more valuable might be found among the storehouse of organic molecules. The answer to life, the universe, and everything.
How do you go from such simple material like carbon and hydrogen and oxygen and nitrogen to something which asks questions about where it came from? That's a huge leap. And on Titan, there's a real good possibility that some of those really difficult to understand intermediate stages actually occurred. It hasn't gone to completion, at least we don't think it has, although there are some people who think that if we go to one of Titan's lakes, we will discover Titanian bacteria that have figured out how to metabolize liquid methane.
Well, that's not a liquid that we, life forms on Earth like, but maybe a life form on Titan that grew up with liquid methane would be perfectly comfortable there and would look at shock at the thought that organisms would live in water. Oh my God, those things on Earth living in water. Pity those poor Earthlings. We live in liquid methane, much more pleasant.
Titan is the ultimate test for life in our solar system. If life exists under these alien conditions, then you might find it anywhere. The Huygens mission will not be our only trip to Titan, nor Cassini our last visit to Saturn. These are just bold first steps on a journey that's just begun. Even before the mission is over, Cassini has left a thirst for a return trip. Planetary explorer Jonathan Lunine and aeronautical pioneer Julian Knott think they know the perfect way to do it. A robotic hot air balloon.
So what we're flying over now is very much like the Huygens landing site. And I'd love to see those ravines on Titan, those steep valleys where the methane is flowing and carving out the hills, very much like what we're seeing now.
The dream is to return to Titan and drop a robotic balloon into the atmosphere. A radioisotope generator will provide the electrical power and the waste heat to give the balloon lift in the chilly atmosphere.
Titan has a dense atmosphere, it's cold, the gravity is low, the winds are gentle, so ballooning is very easy.
I think this flight just makes the point so beautifully why a balloon is a wonderful way to explore Titan. If you're over an interesting area, it's very easy to come down, maybe even land on the surface, lower instruments down,